In this screencast, I'm going to show you how you use your calculator for regression analysis and for finding a regression equation. There are some slight changes to what you're going to see on this screen versus what most of you are going to see on your calculators, just because this is an older version of the software. So I'll try to make sure that's understood while you are while we're going through this. The first thing that you want to do is, because you are doing a regression analysis, you want to be able to use the built-in statistics in your program to be able to figure out how good that analysis is. So that's why you have to turn on diagnostics. And in particular, what we want to look for, and what that does is it gives you what's called the correlation coefficient, that R squared. And it tells you how good your data points fit the line that you have created or the graph that you've created. To do that, you're going to go into Second Catalog. And when you do that, you scroll down to the D, and I'm not going to, well, I'll see if I can do it without scrolling too far. So you want to turn diagnostics on, is what it's called. Let's see if we, and I don't know of any shortcut to get there other than scrolling. But the good part is, once your diagnostics are turned on, unless you reset your calculator, they will always stay on. So you only have to do this one time. So we should be getting close. And you will know if they're not turned on if you cannot find your R squared after you do your analysis. So here's the diagnostics. We press click for on. You'll note that the blinking cursor is at the end of the line until you press it again and it says done. They are not actually turned on. So now we've got them turned on. Let's go ahead and clear that screen. And I've started from the point of actually having data in my tables. So let me show you where that is. So it's under the stat file, or the stat button, and then edit. So just press enter, and you're going to see all your data for these types of regression are going to be in L1 and L2. Your input data, your x's come in L1, your y's, or your output data is in L2. So I'm using the example about the temperatures from problem 3 on page 211 in your textbook. It has to do with the temperatures in Sacramento. So in L1 is the time of day, and you can see here that once I get to 14, I've converted the time to military hours to indicate that 2 p.m. is later than noon. If I just use another 2 here, I would have some really oddball looking kind of data. So I've got all the times in L1, or my x, and I have all the actual temperatures in L2. So I've already done that part, but I want to have you note a couple of things. See where this dotted line or dashed line is at the end of the data set? That tells you that your data is everywhere prior to that line. If you have additional data in here, like even if it's 0, 0, it is incorporated into the analysis as another point. So if you've got 0, 0 in there several times, it's not nothing. It actually is a data point, and it's going to mess up your calculations. So make sure that your last data point is then followed by these dashed lines. Okay, so now the data is in there. Let's quit out of here and look at y equals. Most of you are probably going to have some kind of equation still remaining in there. You need to have y1 available for your calculator to put the regression equation that it comes up with. So first thing you want to do is go in here and clear out anything that you have in any one of the y1, y2 values. So make sure that those are all blank. If I were to graph right now, you're going to see nothing, which is good. That's what we want. But the problem is, unless I tell the calculator to go and look for that data that was in those L1 and L2 columns, it's always going to come back and look to try to graph something out of Y1 through Y whatever. Unless I move up here and turn on plots. There's another way to do it, but this is the fastest way. So once I scroll up and hit enter, it is now backlit, and you can see that I've turned the plots on. So now I should be able to see my data. But oops, it's not there. Your calculator always resets to the standard format where 0, 0 is in the center of the screen, and you have about 10 tick marks off in each direction. If you remember my temperature data, though, it's way up here in the 50, 60, 70 range, so I'm never going to see it with this particular window. Now you can go into the window and start messing around and changing it and try to estimate it, but that's really a lot more work. the fastest and easiest thing to do is just come into your Zoom catalog and come down to option number 9. Hopefully I won't scroll past it. And you'll see that option number 9 says Zoom Statistics. So it says center the data around my statistical data. So center the plot around that. I can do Zoom 9, or I can just do the way that I did right now. So now I see all my data points. And you want to look at your data before you do any regression, because the shape of the data and the curve that it follows is going to give you an indication of what type of regression you want to do. In this case, it looks like a parabola, so I want to do a quadratic regression. Okay, all of the regression options are under the same screen here under statistics. Instead of coming in here and editing the data now, we're going to come over and do some calculations from it. And again, I have another table of options that comes up. You can see option number 4 is a linear regression. If this were a straight line, I'd want to use linear regression. It's not, but it's quadratic. And in the coming months, we're going to be looking at cubic and quartic regression. But we know this one looks like a quadratic, so I can scroll down or type in the number 5. And at this point, you're going to see some things different on this screen versus what you're going to see on your calculator, assuming that you've had your software updated. If your software is updated, you're going to see this nice little table that's going to come up. And the first line is going to say what your X values are in, that they're in L1. Your second one will say that their Y values are in L2. Then it'll talk about a frequency equation, which we don't use, so don't worry about that. But then the next line will talk about storing the regression equation. So the process that I'm about to show you right now is going to be the same one that you have to do in order to make sure that your equation gets stored back into that Y1 slot and you can see it on your calculator. So right now all we see is the data points, and if I were to run through and do the regression, which I am going to do right now, you can see that I will come up with everything that I can see in order to create my equation. So the equation looks like 0.469 x squared plus 14.72 x plus 36.1. And my r squared looks to be pretty tight here. It's almost 1, so it's 0.99, which is nearly 1. So it's a very good correlation. But if I were to go in now and plot it, all I'm going to see is just my original points because I have nothing stored in Y1. In order to see that equation and then to be able to use the calculator for calculations off of that, you have to store the regression equation in Y1. And here's how you do it. So again, we're going to come through and run the regression. And for most of you, you're going to just scroll down to that point where it says store regression equation. If you've got the older version of software, you're going to leave the screen right here. But the next step for everybody is going to be pressing vars for variables and then scrolling over to Y variables. Just leave it on function, and when you press it there, it gives you the option to put it into any one of the Y1, Y2, Y whatever. So now that I have it as Y1, this Y1 will pop up in your table that most of you will see, or if you've got the older version of the software, it's going to look like this. And now you can press the calculate key, or for me, it's just an enter at this point. And now I come up with the same thing that I've seen before, but the only difference is now my graph shows up as well, which you can see right here. So again, the same correlation, same equation, and now when I look at the screen on the calculator, here's what it looks like. And that's what you should see as well, regardless of which version of the software you have.